Good morning, friends. Our next chapter is sequencing and scheduling. It is also another important chapter, same as the forecasting. So, one numerical from this scheduling and one numerical from forecasting that can come in your exam. So, basically, what is the syllabus of that particular chapter? That is, first of all, we are understanding what is the sequencing and what are the scheduling. We know that we have already forecast the demand. Suppose our demand is 1000 unit. So, to produce 1000 unit in our industry, what are the different things that we have to take care, and what are the sequence of job, which resource is assigned to which worker, which machine, that all the things that comes into this chapter. So what is the sequence? So sequence is order of loading or processing job on machine. It means suppose you have a different five machine. So which job is preferred on which machine, that sequence that we have to carry out. And what is the schedule? That is the allocation of resources to job with respect to time. So it is a timetable of job where in times and out times are specified. So basically what is the meaning of sequencing and scheduling? That is a one type of timetable. Okay. Now what is the meaning of, or what is the main objective behind the learning of this chapter? So the main of the sequencing and scheduling is to get optimum job sequence. It means you have to find out the optimum job sequence which can minimize average flow time, average tardiness. What are the different, these are the things that we are going to study by numerical. Number of delay jobs, maximum lateness, and what is a max span. Okay. So first of all, let's go for a assumption. So what are the different assumptions during the sequencing and scheduling? That all parameters are deterministic in nature and all jobs are ready for processing. It means there is no waiting time for job. Machine is flexible to carry out any type of job without breakdown. Okay. No preemption, that is job cannot be unloaded without completion. You can complete, you have to complete a job. Traveling times are neglected in case of more than one machine. Okay. So that is somehow the assumption. Now we are looking from the main topic, that is n job one machine. So what do you mean by n job one machine? Suppose we have to carry a number of jobs and we have only one machine. So which job is processed first, which job is second, which job is last? That sequence that can be carried out the n job one machine problem. Okay. So what is the objective to get an optimum job sequence? We have total different types of solution techniques. This method we have to study here. So the first technique, that is known as a shortest processing time. Your job sequence will be based on processing time. The job which has the lowest processing time, that has a highest priority. The job has a largest processing time, that is a last priority. Second, earliest due date. Due date, it means it is a date at which you have to complete your job. Your job must be completed for customer satisfaction. So that is known as a due date. So the second method, that is earliest due date. You have to sequence your job according to the due date. It means suppose we have a three different jobs and the due dates are for first job our due date is 2 days, second job that is fifth, and third job that is fourth. So we have to sequence a job like 2, 4, and 5. It means 1, 3, and 2. This is a job sequence. Then first come first serve. It means whoever come first, service will be first. Last come first come. Whoever comes last, service will first. Critical ratio. What is the critical ratio? We will see least lag and longest processing time. So these are the methods that we are using during these solution techniques. Okay. Now look at the first method, that is known as the SPT rule. SPT rule, shortest processing time. So shortest processing time is given a highest priority and proceed a first job, that is a job sequence is formed in increasing order of processing time. It means first sequence will be that which has a lowest processing time, and if tie occurs then use minimum due date. Okay. What are the merits? SPT rule can minimize average flow time, number of tardy job, total shortage cost. Second method, that is earliest due date. Job sequence is formed in increasing order of due date. It is the same as shortest processing time. Okay, this method is known as EDD rule. So EDD rule can minimize average tardiness and maximum lateness. Okay. Let's look at some of the numerical. These are the jobs 1, 2, 3, 4, 5, and these are the processing time. So what is the average flow time using SPT rule? It means first of all you have to look at the what are the job sequence by using the SPT rule. So for the use of SPT rule, you have to give you have to give job sequence. First job sequence, that is least processing time, that is 4. Second processing time, that is 7. Third 11, 13, 14. So your job sequence will be 2, 3, 5, 1, 4. Now your job will start at 0 time, so flow time will be 4. After completion of second job, your time will be 4. After completion of third job, your time will be 4 plus 7 of third, that is 11. After completion of 5 number, 11 plus 11, 21. After completion of first number, 21 plus 13, 35. 35 plus 14, 49. Now we have to find out average flow time. Average flow time, it means you have to take average of all these. So first of all, take a summation of all, that is 121 divided by 1, 2, 3, 4, 5. It means 24.2 minutes. So what is the significance of average flow time? Average flow time gives a average time at which any job can complete. It means if you 24.2 and if you multiply by 5, that will give you 121. Here, after the end of 49 minutes or 49 days or 49 year, your this complete 5 job that will be completed. So this 49 is known as a max span. In question, if they ask what is the max span, so max span will be a 49. What is the summation of average flow time? That is 129. What is the summation of flow time? That is 121. What is the average flow time? That is 121 divided by 5, that is 24.2 minutes. Now you look at next example, that is a job again and processing time. So you have to find out the average flow time using SPT rule. So we have want these are the job sequence as per the shortest processing time. Take a 4 plus 5 9, 9 plus 6 15, 15 plus 8 23, 23 plus 9 31, 32, 32 plus 10 42. So your max span will be 42. Average flow time will be summation of this 125 divided by 5 6, that is 20.83. Okay. Now these are the most important question. From here we can comparison both the rules SPT as well as the EDD. Okay. So we have different jobs 1, 2, 3, 4, and we have different processing time 4, 7, 2, 8 due date. So here we have to solve this problem by both SPT and EDD rule. So first of all, let's solve by EDD rule. So what EDD says, my job sequence will be on based on due date, that is 6 9 17 90. Okay. So my due date will be 6 9 17 90. My job sequence will be 1 2 4 3 1 2 4 3. So my processing time for 1 2 4 3 4 7 8 2 4 7 8 2. What is my flow time? That is 4 4 4 plus 7 11 11 plus 8 90 90 plus 2 21. So average flow time you can calculate by summation of all these divided by 4. What is due date they have given? Now your flow time is 4, your due date is 6. It means if I start my work at 0, I can complete this job in 4 days and my due date is 6 days. So I can say I am early to schedule. So my lateness will be minus 2. That is due date minus flow time. I can complete this job is 11. Suppose it is a March. So I have to complete the job. Due date is 9, it means 9th March. And I can complete a job by 11th March if I start at 1st March. So I am late to the schedule by 2 days. Same way, I can complete a job at 19th March, but my due date will be a 17th March. So I am late, that is 2 days. Same, I can complete a job 21st March, but my due date is 19th March. I have to give my work by 19th March. So my due lateness is 2. So what is a tardiness? Tardiness is a positive of lateness. Okay, if it is a negative lateness, so we don't have any type of issue. We are earlier to schedule. So tardiness will be 0. If I have a lateness in positive, that same will be a tardiness 2 2 2. So what are the total tardiness? 6 2 2 2. Number of tardy job. How many jobs that I have wait? 1 2 3 jobs. What is flow time? Summation of all divided by 4. What is the average tardiness? 2, 6 divided by 4, 1.5. What is the maximum lateness? What is maximum of late? 2. That is 2. The same numerical if we solve by the SPT rule. So by SPT rule, my job sequence will be 3, 1, 2, 4. Okay. So my flow time, okay, 2, 4, 6, 6, 7, 30, 13, 8, 21. My due date, that will be same. What is my lateness? I have to complete the job by 19th March. I can complete 2 March. So my lateness will be minus 70. 6, 6, 0. I can complete 30, but my due date is 9. I am lating by 4 days. 21, 7, again I late of 4 days. So what is the tardiness? Negative, that will be 0, 0, 4, 4. My flow time will be summation of all this divided by 4. My tardiness sigma 4 plus 4, 8. Number of tardy job, so here only 2 tardy job. And here what is flow time? All divided by 10.5. What is the average tardiness? 4 plus 4, 8 divided by 4, 12. If I make one table of SPT and EDD rule, so I can say that here average flow time for SPT rules, EDD rule for all the 4 things. From this figure, we can say that SPT rule can minimize average flow time and number of tardy job. EDD rule can minimize average tardiness and maximum lateness. So from here, as per our requirement, we can use either SPT or EDD rule. There is no thumb rule that we have to use only SPT or only EDD rules. Okay. So SPT rule, be remember SPT rule can always minimize average flow time and number of tardy job. EDD rule can minimize average tardiness and maximum lateness. Okay. First come first serve, same sugar, but you have to select a job sequence by first come first serve. Last come last serve, you have to select a job sequence by a last come first serve. Okay. What is the critical ratio? Critical ratio, that is what is the time, or that is the third method. What is the time available divided by work to be done? Suppose critical ratio, it means 1. So what is it critical ratio? That is due date minus today date minus processing time. Suppose you have to complete your work by 15th March and today is 5th March. Okay. So I can say 15th minus 5th, it means 10. And suppose you have a processing time of 3 days. So 15 minus 5, 10 divided by 3, it means 3.33. So whenever a critical ratio 1, it means you are on schedule. Whenever critical ratio is greater than 1, it means non-critical job. You are leading the schedule, but it is a dangerous. Whenever your critical ratio is less than 1, it means it is a critical job. You are behind of schedule. So to understand these things, let up one numerical. Take we have a job ABCD, due date, processing time. The question is find job sequence using critical ratio method, and today's date is 6. So I can say my critical ratio is today's date minus due date. Okay, 6 minus 10, due date minus today's date, divided by processing time, that is 4. So by taking this equation, we can find out all the critical factor. Okay, and from that, which has the lowest critical ratio, that will be first sequence B, then A, then D, then C. So B, A, D, C, that will be sequence. Last one, that is least slack. Least slack, it means slack. What is a slack? That is the difference between due date and processing time. 8 minus 5, 3, 10 minus 7, 3, 5 minus 4 minus 1, 5. If your job sequence will be on least slack, that minus 1, 3, 3, 5. If there is a tie, then use minimum due date. Okay. So these are the some important topic of n job 1 machine. Okay. In next video, we are going to discuss about n job 2 machine. How to solve n job 2 machine? N job 2 machine, it means your number of job, each job has to proceed for 2 machines. Okay. Here only that is a 1 machine. So these are the important numericals regarding to the scheduling. Okay. I will given one assignment to the scheduling, solve it and submit it by tomorrow 3:30. Okay. Thank you.